Hey guys, in this video the lovely Mr. B is going to be taking you through quadratics for your AS and A-level maths. Now there are lots of examples here, work through slowly at 3 different levels, and you can use the timestamps to jump between the levels as you see fit, as you feel confident or capable. You can use this as a revision or to learn new things. Now if you want a load more practice questions, then over my website there are thousands of questions waiting for you.
We are going to have a look at 3 methods to solve quadratic equations, gradually increasing in difficulty. So the first method we'll look at is by inspection. Now, if we take a pair of double brackets, so let's say we've got x plus 3 and x plus 1, and we need to expand these brackets. So we do x times x is x squared. We do x times 1 is 1x. We do 3 times x is 3x. And we do 3 times 1, which is 3. And this gives us an expression with 3 terms. We've got the squared term, x squared. We've got the x term. Now we've got 2 of these, but 1x plus 3x is 4x. And then we've got the number term, which is plus 3. Now, when you're factorising quadratics, you're going to be working backwards. So we're not going to be expanding brackets to write an expression. We're going to be taking an expression and putting it back into brackets. And you can see the answer here, x squared plus 4x plus 3, is the same as actually the question I've got on the page here. So the question here is, how do we work backwards? Well, it's all about spotting patterns with the x squared, the 4x, and the plus 3. Now I'm just going to rub out the guidelines for multiplying out because I need to write some more things around these brackets. So the first thing we're going to look at is the plus 3 at the end. And we're going to think, well, how do we get the plus 3? And the way we get the plus 3, you might see that we have a 3 and a 1 in the brackets. And so the 3 has come from multiplying those 2 numbers together. How do we get the 4x? Well, again, we can find the 4 in the numbers inside the brackets. We've got a plus 3 and we've got a plus 1. Now, if you add those together, you get the number in our final expression. 3 plus 1 is 4. Then at the start, we've got the x squared. So where does that come from? Well, we've got the x at the start of both brackets. X times x is x squared. So the thing to take away from this is the middle term is the 2 numbers in the brackets added together, and the final term is the 2 numbers in the brackets multiplied together. So let's look at how we do this now going forwards. So we start off with x squared plus 4x plus 3. We would say to ourselves that we know that we want 2 numbers which multiply together to make 3 and add together to make 4. A good method is to write a factor list for the number at the end. So we have 3. So we want a factor list for 3. And the only factors 3 has, the prime number is 1 and itself, 1 and 3. Then we look at our factor list, we think, well, do they add up to 4? And they do add up to 4. So then from our factor list, we can clearly see that this is going to be x plus 1 and x plus 3. Now, you'll notice my original example is x plus 3, x plus 1. It was the other way around. So you can see that it doesn't really matter which way around the 2 brackets are. You can write your answers either way around. So I could write x plus 3, x plus 1, or x plus 1, x plus 3. So now we can see how we go both ways. Let's focus on practicing on factorising quadratics. So our next example is x squared plus 3x minus 40. And we know that we want 2 numbers which multiply together to make negative 40. And you do need the sign before it included. And those same 2 numbers are going to add together to make 3x. And again, include the sign before it. It's going to be a positive 3x. There's also the x squared to find. So with the x squared, we can put down our double brackets. We know that x times x is x squared. So that part's dealt with. So we'll just need to now work out our middle and final term. So the way to do it is look at your final term, it's a 40, and look at the factors of 40. We can divide it by 1. We can divide it by 2. We can't divide it by 3. We can divide it by 4. We can't divide it by 5. You can't divide it by 6 or 7. And you can divide it by 8, but we've already got 8 in our factor list. We've got our complete list of factors now. So we just divided it by all the numbers, one at a time, from 1, 2, 3, 4, 5, 6. Starting with the smallest number, working our way up until we had a repeat. Also, these numbers, when I divided them, the answer is also a factor. So I've got 4 options. Now, one of these options is going to give us 3. Which one's it going to be? Now, if you add them up, you're not going to get 3. But if you look at 5 and 8, if you do a takeaway, you're going to get 3. So how we get 3 from this? It'd be 8 take away 5. So we want a positive 8 and a -5. So we put those in our brackets. So we want x plus 8 and x minus 5. And again, you can write those in either way around. Now, an optional extra step you can do here is, once you've done your factorisation, you can check it. And the way to check it is to multiply that out. So let's multiply out our brackets and see what we get. Now, I would suggest doing this most of the time you've got time in your exam. I'm going to do it once in this video, but just be aware it's something you can do. So x times x is x squared. X times -5 is -5x. 8 times x is 8x. And 8 times 5 is 40. And that's an 8 times a -5, so it'll be -40. Our middle terms, we've got an 8x and a -5x. So altogether, they would make a positive 3x. And you see, by multiplying out my answer, I've got back to my original question. Now, if you made a mistake with this and then you multiply it out, you should find that you actually get a different answer to what your original question is, and that's the way you know that you've made a mistake. Our next question is 2x squared plus 11x plus 14. So again, when you want two numbers that multiply to make 14, and it must be a positive 14, and two numbers which add together to make positive 11x. We also have our x term at the start, and we can set up our brackets straight away with the x term. So we know it's going to be double brackets. It's quadratic, like a little 2. That means 2 brackets. X times x will give us x squared, but you'll notice it's 2x squared. So we'll need 2x times x in our brackets. Let's have a look at the list of factors of 14, see which factors will make 11 for us. So let's divide by 1. That's 1 and 14. Divide by 2. 2 and 7. And 14, it's not a prime number, but in some ways it's almost a prime number because it doesn't have a lot of factors. And this is something common to the 7 times table. We can't divide it by 3 or 4 or 5 or 6. So we only have 2 sets of factors for this. Now, which ones are going to make 11? So if you add them together, we get 15 and 9. That's not 11. If we take them away, we're going to get 13 and 5. That's not 11. So what's going on with this kind of question? Well, you'll notice that we've got the 2 in the 2x. And that means that when you multiply this out, that 2x is going to multiply the second term by 2. That means that we're allowed to multiply one of our 2 factors by 2. So how are we going to get 11? Well, what are our options? So we multiply by 2, we could have 2 and 14, or we could have 1 and 28. So that's just, multiplying either one of the 2 options by 2. Now, neither of those are going to give us 11. We could do 14 take away 2 for 12, that's the closest. Let's look at 2 and 7. So we can multiply the first number by 2 and get 4 and 7, or multiply the second number by 2 and get 2 and 14. Now again, 2 and 14, that's going to give us 12 we take away. That won't work. But with 4 and 7, if we add these together, we're going to get the 11. And so they're both going to be positive. So that's the one we're looking at. Now, the important thing here is when you write in the answers, you have to write in the original numbers. So I can't write in 4 and 7, it's got to be the 2 and the 7. It also matters which way around, because the one I'm multiplying by 2 was a 2. 2 is being multiplied by 2 to make 4. So we write in 2, but that is going to become a 4 when you multiply it all out. And that was positive. And then the other one was a 7. So it's going to go like that. Now you can swap the position of the 2 brackets. So you can have x plus 2 and then 2x plus 7 the other way around. But you can't swap the position of just a 2 and just a 7. You can't have 2x plus 2 and x plus 7. It's got to be specifically that the plus 2 is in the opposite bracket of the 2x. So when you multiply it out, it is multiplied by 2 to get your answer. If you're not convinced, you can do like I did with the previous question, and you can multiply out that bracket, and you should end up back with the original question. The last thing to do is, if you've left some working out on your answer like I have here, I've got the times 2 around there, just write out the answer again without any extra working out. It's really clear what your answer actually is. Our next question is 3x squared plus 28x plus 32. So we need 2 numbers that multiply together to make a positive 32. They are going to add together to make a positive 28. And I'm going to set up our brackets so we get a 3x squared. That must be a 3x multiplied by an x. Now we need to fill in our 2 numbers. Let's look at the factors of 32, see which numbers multiply together to make 32. You divide it through by 1. 1 times 32 is 32. Divide it by 2. 2 times 16 is 32. We can't divide by 3. We can divide by 4. 4 times 8 is 32. We can't divide by 5. We can't divide by 6 either, or 7. And then we can divide by 8, but we've already got that. So we're repeating ourselves now. We've got our complete list of factors. we've got 3 options. Now, before I look at which one is going to give us 28, we have to remember that the second number is going to be multiplied by 3 when we multiply out our brackets. So what I'm going to do now is write out the options from the start where the multiply by 3 is taken into account. So let's multiply all the numbers by 3. If we multiply the 1 by 3, we get 3 and 32. If you multiply the 32 by 3, that's going to give us 96. That'd be 1 and 96. Clearly, that's going to be way too big. We're not going to get 28 from that. Let's look at 2 and 16. 2 times 3 will give us 6. And 16 times 3 is going to give us 48. 4 times 3 will give us 12. And 8 times 3 will give us 24. So we have to look at this now. So this is, the methods by inspection. We have to inspect our list of options. We've got 6 options. Which one is going to give us 28? And we do have an option that will give us 28. It's the last one we looked at. 4 and 24 will give us 28. But remember, we're not going to write in 4 and 24. We have to write in the original numbers. They were originally 4 and 8. Which one was multiplied by 3? It was the 8 that was multiplied by 3. And the other number was a 4. So our final answer is 3x plus 4 and x plus 8. And again, let's just write it out a final time to make it really clear what our answer is. Now, since this was the same as our previous question in terms of the method, let's introduce something new. So sometimes you're going to be asked to solve an equation like this, and your question won't be 3x squared plus 28x plus 32. You might get something like 3x squared plus 28x plus 32 is equal to 0. So in every step, let's write that equals 0. So what do we do if it's equal to 0? We're not just factorising, we're solving the equation. Now, a nice trick you can do is, if it's equal to 0, and if it's not, rearrange it so it is that if you multiply any number by 0, you get 0. That means if we can make one of the brackets equal 0, the entire equation will equal 0. So, for example, in our second bracket, we've got x plus 8. If x was equal to negative 8, then that bracket would read negative 8 plus 8, which is 0. That means we're multiplying the first bracket by 0. So no matter what value is in that first bracket, if x was negative 8, and that would be 3 times negative 8 is negative 24, and add 4 to negative 20. Negative 20 times 0 is still 0. So that first bracket is now irrelevant. So we know that x equals negative 8 is a possible answer. Now, we always get 2 answers out of these 2 brackets because our first bracket, that could equal 0 as well. Now, what would that have to be to equal 0? So 3x would have to equal negative 4 to make that equal to 0. That means that x, if we rearrange this, divide both sides by 3, x would need to be equal to negative 4/3. So now we have 2 answers. If our equation is equal to 0, then x could be equal to negative 4/3 and x could be equal to negative 8. So there we have our 2 possible answers, just by making one of the brackets equal to 0. And what we're doing from this point onwards is for all our questions, we'll also be solving them to be equal to 0. So if you ask to factorise, you write down the pair of brackets. If you ask to solve it equal to 0, then you need to do this extra step. Now, our next question looks the same. So we have 4x squared, take away 12x, take away 7. But there's a bit of a twist to this one. So let's look at what we need to do. So we need 2 numbers which multiply together to make a negative 7. So we'll have negative numbers involved in this one. It's likely to be a subtraction in here somewhere. 2 numbers which add together to make negative 12. And our brackets need to be set up to give us 4x squared. Now you might be tempted just to write down, well, that should be 4x times x. And then you carry on with your method. However, there is another alternative. There's 2 ways to get 4x squared. You could have 4x times x, or you could have 2x times 2x. And so if we're solving by inspection, we have to take both possibilities seriously. And it's going to mean doing double the amount of work. And this is the reason why we're going to move on to another method next, which might make this a little bit easier. Now, fortunately, the factors for 7 are pretty simple. It's going to be 1 and 7. So we definitely know we're going to have 1 and 7 in our brackets. It's just which way around they're going to be. So let's look at all the options. If we have the alternative with 4 and 1, we could multiply the first number by 4, and we could multiply the second number by 4. So there's our 2 options for that. Now let's look at our second option. With our second option, we multiply both of them by 2. We've got 2x on both sides. Now since they're both the same, there'll be one option from this. That'll be 1 and 14. So we've got 3 different options. Now, which one is going to give us a 12? So 4 and 7, they can add together make 11. That's too small. 1 and 28, 28 is way too big to do this. The 2 and the 14, 14 take away 2 could give us negative 12. So it looks like that's the one we're going to look at. Now, since both numbers are being multiplied by 2, in this situation, it doesn't actually matter which way around we put the numbers in. So we're going to put in 1 and 7, and that'll be the end of it. Let's get rid of our first option, because we're not using that. The 1 is being multiplied by 2, and the 7 is being multiplied by 2. Now, the 1 is the number that became the negative 2, so the 1's got to be a negative. And so there's our answer. 2x minus 1 and 2x plus 7. Now, again, we're going to have a look at what if it's all equal to 0. That would mean that 2x minus 1 and 2x plus 7 multiplied together is equal to 0. So we'd only want to make one of the brackets equal to 0 to get a possible answer. If our first bracket was equal to 0, then 2x would need to be equal to 1. Dividing that through by 2, x would need to be a half. Then looking at our second one, 2x will need to be equal to negative 7 to make our second bracket be equal to 0. Dividing through by 2, x would need to be equal to negative 7 halves. Last thing I do, just make the answer really, really obvious. X could be equal to a half, or it could be equal to negative 7 halves. If you wanted to as well, you could change 7 halves into a decimal. Maybe you could write 3.5. You could write 3.5. But all those answers are the same practically, so it shouldn't really matter which one you write. Now, with the last question, we saw the limits of inspection, because sometimes you can have so many combinations, it's going to be difficult to write them all out. With our last question, because we had 2 different options on how to get the 4x squared term, that doubled the number of options to inspect. Luckily, it was the factors of prime number, so we had a relatively short list. But if we had a longer list, like we had with 32, then we'd have quite a lot to look at. Also, inspection can fail. So let's look at this question. X squared plus 4x plus 6. You want 2 numbers that multiply together to make positive 6 and add together to make negative 4. So we look at our factors of 6. We can divide it through by 1 and by 2. We've got 2 different options for our factors. It's an x squared question, so it must be x times x. And there's no options here for multiplying any of our options by a number. We've just got the options we've got. Now, which option is going to make a negative 4? Well, 1 and 6 can make 7 if you add them, or 5 if you take them away. 2 and 3 can give you 5 if you add them. They can give you 1 if you take them away. None of these options give us 4. So here we have a question that's impossible to do with inspection. And the reason for this is it might be that it's actually a fraction we need to put in here, or there might be something else going on. So what we're going to do is we're going to have a look at some other examples, and then we'll come back to this example. So with our next example, we're going to look at something called completing the square. X squared plus 3x plus 2. Now, the completing the square method, what you do is you're going to have the numbers that you have here. So x squared plus 3x, we're going to reduce that by half. So we're going to say x plus 1.5x, like this. I'm going to make the whole thing squared. Now, we're going to look at what this gives us if we multiply it out, because we've taken this from just the first 2 terms. We haven't really taken into account the final term. So this bracket here, by reducing the coefficient on the x by half, 3 becomes 1.5. By changing the squared into a single x, these 2 things should be the same thing. So let's multiply it out and see. So we have x squared plus, I'm going to write it as a top heavy, 3 over 2 is the same as 1.5. We're going to multiply it out, so let's write the same bracket twice. So we're going to do x times x is x squared. X times 3 over 2 is 3 over 2x. The second 3 over 2 times x is another 3 over 2x. Then 3 over 2 multiplied by 3 over 2, that would be 9 over 4. Combine the middle 2 terms, and we have x squared plus 6 over 2x plus 9 over 4. With a 6 over 2x, we can simplify that fraction. 6 divided by 2 is actually 3. So let's compare this to what it came from. This bracket, x plus 1.5 and all squared, that should multiply out to give us x squared plus 3x. But when we multiply it out, we do get x squared plus 3x, but we also get something extra. We get a positive 9 over 4. So to make what we've written equal to where it came from, we have to take away the extra 9 quarters. And of course, at the end, we've got to write the plus 2 as well. So completing the square is a process where you have the coefficient on your middle term and put it into brackets, but that's not going to give you an accurate answer. And so what you have to do is correct it. And the way you correct it is you square that second number of the bracket, the 1.5, and you take it away. So then what you do have does represent where it came from. So everything I'm highlighting in green here is equivalent. X squared plus 3x is the same as x plus 1.5 all squared, take away 9/4. And then we have the plus 2 on the end. In the next step, we can actually combine together the negative 9/4 and the 2. So we have our bracket, that's not going to change. All right, it's 3/2 this time. 3/2, 1.5, same thing. Negative 9/4 plus 2. Now 2 is actually 8/4. So we add 8/4 on, we're going to get negative 1/4. So that's our factorization by completing the square. And it just means you have another number on the outside of the bracket. So not everything is going to go into the brackets. The next thing to think about is, what if this was all equal to 0? And what it was an equation we want to solve. So we have the factorized version. What do we want to equal to 0? Now, it's not as simple as making the bracket equal to 0 because we have the negative quarter on the outside. So even if we do multiply by 0, we're still taking a quarter away. So that method's not going to work. What we can do, though, is treat it like solving an equation. So we can add a quarter to both sides. That will give us x plus 3/2 squared is equal to 1/4. Then we can square root each side. That will leave us with x plus 3/2 on one side. So we've square rooted the left-hand side to get rid of the squared. We also have to square root the right-hand side. And the square root of a half, the square root of 1 is 1, and the square root of 4 is 2. So we can square root the numerator and denominator separately, and that will work out. Now, an odd thing when you do the square root of something is that you can have a positive and a negative answer. And let's look at why that is. So up at the top, I'm going to write in pink. Therefore, the square root of 9 is 3. So that looks pretty straightforward. But what's negative 3 squared going to give us? Negative 3 multiplied by negative 3 gives us 9 as well. So then working backwards, the square root of 9 could also be a negative 3. So there's two possible answers. So the way we get around that is when we write down 3 as the answer to the square root of 9, we can write a plus and a minus symbol that shows it could be a plus or it could be a minus. Now, you're going to be used to always writing a positive answer for square roots from GCSE. But at this point now, you need to also be aware that we can have negative answers if we square root something. So going back to where we're up to now working out, when you take the square root of a quarter, we have to say it could be a positive half or a negative half, because a positive half times a positive half is 1/4, but also a negative half times a negative half is 1/4, because two negatives cancel out to give us a positive. That means our next step of the equation, we're going to take 3/2 away from both sides. That gives x is equal to plus or minus a half, take away 3/2. And that looks very confusing. So what we're going to do is split that up into two separate versions. One when a half is positive and one when a half is negative. Our positive version would be x being equal to the positive half, take away 3/2, and a positive half, take away 3/2, would be negative 2/2. And we can simplify that. 2 divided by 2 is 1. So that'll be negative 1 as a potential answer. Then we have the version where a half is negative. X would be equal to a negative half, take away 3/2. Altogether, that'll be negative 4/2, and we can simplify that fraction. 4/2. 4 divided by 2 is 2. So that gives an answer of negative 2. There's a lot going on here, so let's write it nicely clear what our final answer is. So x could be equal to negative 1 or negative 2. There are two possible answers. Now, that was quite complicated, so let's look at another example. So we have x squared plus 4x plus 4. So we do the completing the square method. We take our first two terms, x squared becomes x, and 4x becomes 2x. We've reduced it by half. In fact, we don't have an x in the brackets for the second term, so it's just going to be plus 2. And that bracket is going to be squared. Now, again, what you'll find is these first two terms do not actually equal what we've just written down. That's an estimate. It's kind of, it's close enough. What is that actually going to equal for us? So if we actually work it out, x plus 2 multiplied by x plus 2, we get the x squared term, that's correct. We get x times 2 and 2 times x, which altogether is 4x, that term's correct. but then we get the 2 times 2, which is 4. And that's not correct. That's not actually coming from the first 2 terms only. So what we need to do is we need to adjust it, and we need to take that 4 away to make an adjustment. And now the section that I've highlighted in green on the top row is the same as the section highlighted in green on the row underneath. The 2 green highlighted areas represent the same thing. So in effect, we are estimating what the bracket's value is going to be by reducing the first 2 terms by half, like we've done here, and then we have to make an adjustment to make sure it actually works out. And don't forget, at the end, we still need the plus 4. Now, this is quite a nice question because a negative 4 plus 4 cancelled out. So actually, the final answer would be x plus 2 all squared. But we've got that answer without having to look at lists of factors. And this method might actually be a little bit faster because the slow part of this method was actually multiplying the brackets at the bottom. But you don't need to do that because to get that plus 4 that we had to adjust for, if you look at the bracket, 2 times 2 is 4. Our second number multiplied by itself is 4. So you don't need to multiply at the full brackets because the first 3 terms, multiplication are correct anyway. So on the fourth one, we multiply the number by itself that we're interested in. So what I can do, I can rub out all this working out because we can get that 4 just by multiplying the number 2 by itself. So this is all the working out you need to complete the square actually. Now again, what if it's equal to 0? So if it's equal to 0, again, we can do this rather than using the trick we're trying to make one bracket equal to 0. We can do it by using our solving equation skills. And so for this, we can square root both sides. That will give us x plus 2 is equal to square root of 0. The square root of 0 is 0. And so with 0, we don't need any plus or minus here because a positive and negative 0 doesn't exist. It's the same thing. Then we can take the 2 away from both sides because x is equal to negative 2. And we only have one answer for this question. We don't have 2 that we've had previously. That's because both brackets have the same value. They're both x plus 2. In that situation, you would have 2 answers. They're just both negative 2. So you only write it down once. So now we're back to our first example. And again, we're going to use the completing the square method. So take the first 2 terms, x squared becomes x, negative 4x will become negative 2. I've reduced it by half. We need to make an adjustment. Negative 2 times negative 2 will give us a positive 4. So we need to get rid of that extra positive 4 that we'd have. So again, the first 2 terms, I'm highlighting in green, have the same value as what I'm just highlighting in green here. One extra thing, I forgot to square the bracket. That's important as well. So those 2 things are the same, and we have to add on the 6. So we can simplify that. We've got the bracket, x minus 2 squared. The negative 4 plus 6 will give us negative 2. So we have factorized it. Now, the next thing to look at is what if our equation was equal to 0? And so we make it all equal 0. So again, we could do this by solving equations. We could add 2 to both sides. Actually, just double checking, negative 4 plus 6 will give us a positive 2. So we have to take 2 away from both sides, actually. That would give us x minus 2 squared is equal to negative 2. Our next step will be to square root both sides. So square root the left-hand side, that will cancel out the square. And square root the right-hand side, we have the square root of negative 2. So we want 2 numbers which multiply together to make negative 2. Now, an odd thing happens here. Square rooting a negative number is impossible because there's no way you can get the same number multiplied by itself to get a negative. If you have a negative times a negative, you get a positive. A positive times a positive gives you a positive. And you can't do a mix, a negative times a positive, because the very thing with a square root is that you're finding the same number twice. You can't have a positive negative version. So our next step is now impossible. We can't carry on because we cannot find the square root of a negative. So what does this mean for our answer? Well, it means that we just write there are no solutions. You cannot solve this equation equal to 0. You can factorize it, but you can't solve it. And so with our last 3 examples, we've seen an example of getting one answer from a quadratic. It is kind of 2, but it's the same answer twice. We only write it once. We can get 2 answers from a quadratic, which is usually what happens. Usually if it's squared, there'll be 2 answers. If it's cubed, there'll be 3 answers usually. But again, you can have repeat answers in those cases. And now we've seen an example where we have no answers. Now, as an extra point with these last 3 questions, there's actually a way to work out how many answers you should be getting from these questions. And that's by using something called the discriminant. Now, we'll talk about this more with the hard questions, but basically, this is a formula which is b squared take away 4ac. You might be wondering where the a, b, and c comes from. That's the first term, the square term, the middle term, the x term, and the third term, the whole number term. And these are always a, b, and c. And if it's rearranged to be a different order, it's always going to be the square term's always A, the x term's always B. So let's have a look at what happens when we actually do the discriminant substitution with each one of these questions. So for the first one, b squared minus 4ac. B is 3, so that'd be 3 squared minus 4 times a. Now there's no number on a, it's just x. That'll be a 1 times c, which is 2. That's 9. Take away 4 times 1 times 2 is 8. That gives an answer of 1. Let's take a look at the second one. So b squared in this case will be 4 squared. Take away 4ac, a is 1, and c is 4. That's 16. Take away 4 times 1 times 4 is 16 as well. That gives an answer of 0. Now let's have a look at the last one. So b squared, that's going to be negative 4 squared, be careful negative numbers. Take away 4 times a, which is 1, times c, which is 6. Negative 4 squared is still a positive 16. And 4 times 1 times 6 will give us 24. 16 take away 24 is negative 8. So what do these answers from the discriminant mean? So for the first question, we have a positive discriminant. And you might remember that this question had 2 answers. So if b squared minus 4ac is a positive number, it's more than 0, that means we have what we call 2 roots, or 2 answers. So by roots, we just mean, when we kind of square root the question, we work through it. Our second example, b squared minus 4ac, this one's equal to 0. You might remember this question, this is the one where I had the same answer twice. Both answers were negative 2. So we just wrote it down once. So if it's equal to 0, this tells us that we have 1 root, so we have 1 answer. And our last one, b squared minus 4ac, was less than 0. It was a negative number. And remember that this one, the last one we just looked at, this one didn't have an answer. It's got 0 roots. So if you do get a question where you think, this isn't working out, I'm not getting an answer for it, and I'm just square root a negative number, if you use the discriminant and then the answer to it is less than 0, then you know you're going to have 0 roots. And we'll talk about more about why this is when we get onto the hard questions, because we'll be seeing the discriminant again. So for our next question, we have x squared minus 6x plus 2, and we're going to be completing the square. So when we set up our brackets, we're just going to focus on the first 2 terms, and we want something that will give us this. And a good estimate would be to say x for x squared, and for 6x, we go for 3. So we've halved the second term. And then we make the entire bracket squared. Now we know from the previous examples that x minus 3 squared, if we multiply this out, we won't get x squared minus 6x. There's going to be something extra, and it's going to be the minus 3 squared, which will give us a positive 9. So we need to take away that extra positive 9 we'll get if we expand the brackets. So the 2 green highlighted sections are both the same. And of course, to make it equal to the original expression, we need the add 2 at the end. And we can simplify this. There'll be x minus 3 squared. Negative 9 plus 2 gives us negative 7. And so that's how you factorize by completing the square. And again, you can see this is a good method because there's not as much working out. The difficult thing is remembering to take away the extra number and where the extra number comes from, which is the number term multiplied by itself. Now, where this becomes more difficult is what if it's equal to 0 and we have to solve it. So our first step would be to add 7 to both sides. That will give us x minus 3 squared is equal to positive 7. Then we'd square root both sides, and that would give us x minus 3 is equal to the square root of 7. Now, in previous examples, we've got from this a number that can be square rooted. We had a square number, but in this case, we're square rooting 7. And if we square rooted 7, we're going to get a decimal, and we're going to get 2.6457531, and that number will continue. It's an irrational number. So we don't really want to change it into a decimal form. So what can we do with this without resorting to writing out a really long decimal? So what we can do is we can actually leave it as a root 7, so we have a full level of accuracy. We're not rounding off the decimal. We continue our working out. We're going to add the 3 to both sides. That'll give us that x is equal to the square root of 7 plus 3. And as an extra detail here, what we could do as well is say that it's going to be plus or minus root 7, because the decimal we'll get out of root 7 could be a positive or a negative, like we discussed with previous answers. So how do we write down our final answer? Well, that format is fine enough. We could swap the 2 sides around, and we could write that x is equal to 3 plus or minus the root 7. And if we just put the positive number first, that means we don't need to write the positive symbol, because we just assume that anything without a symbol is going to be positive. So either x is equal to 3 plus or minus root 7, or x is equal to plus or minus root 7 plus 3. They're both the same number. That's the way we write it, which means that we don't need to round our answer. So we're writing our answer using surds. And often questions will actually point this out and say, can you write your answer in the form? It might be something like a plus or minus root b. So it's just letting you know it's okay to write the answer as a surd. If a question, however, asks for a value, it asks for an actual number, then you would actually have to write the decimal. Perhaps a question might say round it to 1 or 2 decimal places. That's when you know that it's not appropriate to write a surd answer, and you actually need to do the square root of root 7. With our next question, again, we're going to complete the square, but we've got a complication. We've got a number on our x squared. We've got 3x squared, then minus 7x minus 2. Now, if we say this is going to be equal to 0 from the start, then there's something we can do here. We can divide this through by 3 to get x squared, and then we can use our method as normal. So let's divide through by 3. 3x squared divided by 3 is x squared. 7x divided by 3, that'll be a hard one, so let's just leave it as 7 divided by 3. And the same thing, dividing 2 by 3 will give us a decimal, so let's leave it as a fraction. 2 divided by 3. And it's all going to be equal to 0. So now we've got an x squared term, now we can complete the square. So before you complete the square, always make sure that your x term is going to be 1x squared. So we set up our bracket, x squared becomes x. We want half of 7/3. Now, a nice trick to make a fraction be a half is to double the denominator and have 7 over 6. So effectively, to make a fraction smaller, you can increase the denominator. So to halve it, you make the denominator twice as big. You kind of work the opposite way around there. If you're not sure about that, then you could do something like an extra line where you do, okay, I've got 7/3. I want to halve it. I want to divide it by 2. We can write 2 as a fraction. We can change this into a multiply to make it easier. Keep the first fraction, change divide to a times, and then flip the second fraction upside down. And then 7 times 1 is 7, and 3 times 2 is 6. So we get the same answer if you do the full method. So do the full method if you need to, but that's a little shortcut you can use. And of course, that's not going to be our final answer, because the first 2 terms we've taken this from, if we multiply it, this bracket, it's not going to give us this. There's going to be something extra. And what's the extra going to be? Well, it's going to be the number term squared. So negative 7/6 squared. Again, nice little fractions. You can square the numerator. 7 squared is 49. And you can square the denominator. 6 squared is 36. And then if you square, that'll be a positive 49 out of 36. So we need to take it away to cancel it out. And now, again, the 2 green highlighted areas equivalent to each other. So all that's left now is to take away the 2/3 and make it equal to 0. Now, simplifying this is going to be a bit of a pain with a 49 over 36, and we're going to take away 2/3 away from it. Looks pretty difficult. However, we can multiply up using equivalent fractions 2/3 to be out of 36. 3 times 12 is 36. So we multiply the 3 by 12 to get 36. We can multiply the 2 by 12 to get 24. And now with our equivalent fractions, we can simplify this. And we're going to get x minus 7/6 squared is taking away 73/36. Now that's all equal to 0, but for our next step, we're going to take our fraction away from both sides, or rather add it to both sides. And then that's just going to leave us with our bracket is equal to a positive 73 over 36. So I've done 2 steps at once there just to speed it up. Now we want to do the square root of both sides. So square root of the left, square root of the right. And again, you can square root the numerator and denominator separately. The square root of 73, we're not going to be able to do. But we can do the square root of 36, it's 6. For our final step, we need to add 7/6 to both sides. And remember that it's going to be a positive or negative when you square root something. So our final answer is x is going to be equal to positive or negative the square root of 73 over 6 plus 7/6. And what you might want to do then is just, maybe swap the sides around and write as a final answer x is equal to 7/6 first. We don't need to write plus or minus the square root of 73 all over 6. If you wanted to, you could write an even simpler form. They both have a denominator of 6, so we could combine it together and write that x is equal to 7 plus or minus the square root of 73 all over 6. And which form you're going to want might depend on the context. If it's just asking for factorization, then we just want to write the kind of brackets we had earlier on. So x minus 7/6 squared equals 73/36. That would do. If you want to solve it, then any of the forms we've written are going to be okay, as long as it's x equals 2. I've got 3 different versions of that. All 3 versions will be absolutely fine. There's rearranged versions of each other. But if the question asks for a specific format, maybe it says you want a plus or minus root b all over c, and that's telling you to use the last form. But don't be too worried about this. I'm probably overcomplicating it. Any of these answers should be okay. Now, you might have noticed with the easy questions, we used inspection, which seemed like it was pretty easy. But as we got towards the end, the examples started to get more and more difficult. Then we had to look at completing the square. And again, some of those looked pretty easy. Maybe it harder to understand what to do, but the working out was a lot less. But the last example just looked at, the working out got really, really complicated. A lot of work with fractions to do. So now we're going to move on to a third method, which is using the quadratic formula. Now, this isn't particularly for factorization. This is for when it's an equation to solve that's equal to 0. And the quadratic formula is that x is equal to negative b plus or minus the square root of b squared minus 4ac all over, that's the entire thing, is over 2 lots of a. Now, there's a few features of this that you've seen already. So when we talked about the discriminant before, you can see the discriminant as part of this equation. The discriminant is the b squared minus 4ac part. And now you might understand why you only get one root if it's equal to 0. Because if that entire square root section is equal to 0, the square root of 0 is 0, you've got plus or minus 0, and so you don't have any alternate answers. So you can't have plus or minus 0, it's just 0, and it's got no value. You might also understand why, if the discriminant is negative, you don't get an answer. Because if that discriminant section is negative, you're finding the square root of a negative number, which is something that you can't do. You'll also notice what the a, b, and c, which we've used before. A is the coefficient on the first term. Very often it's just 1 for 1x squared. B is a coefficient on the middle, in this case negative 3. And C is the number at the end. So we've got a 1, a negative 3, and a 1 for A, B, and C. So all we need to do is substitute these numbers into that formula. So let's write it out again. So x is going to be equal to negative b. That's going to be negative 3 plus or minus the square root of, and we've got b squared, so that'll be negative 3 squared minus 4ac. That's 4 times a, which is 1, times c, which is 1. And all of that is going to be divided by 2 lots of a, which is 2 times 1. Now with the substitution, we can start to simplify it step by step. So negative 3, double negatives cancel out, that'll be a positive 3, plus or minus, so inside the square root, negative 3 squared is 9. We're taking away 4ac, 4 times 1 times 1, which is 4. All of that is going to be divided by 2. Let's move on to a new line. X is going to be equal to, we've got the 3 that's plus or minus. Now we can do 9 take away 4. 9 take away 4 is 5. So it's going to be 3 plus or minus root 5 all over 2. Now, what happens next depends on what you're being asked for. So, for example, you might be asked to give your answer as an exact answer. So you might want to leave a square root involved. You might be asked for a decimal. So in that case, you'd work this out and you would have a decimal answer, perhaps rounded to 2 decimal places. So we have our exact version, x is equal to 3 plus or minus root 5 all over 2. If we want a decimal version, let's take the plus or minus the plus. We do 3 plus root 5, then divide that answer by 2. And for 2 decimal places, we get 2.62. Then we take the plus or minus be a minus, do 3 take away root 5, divide that answer by 2, and we get 0.38 to 2 decimal places. But again, those decimals were irrational decimals, so there would be way more decimal places. So we've lost some accuracy by rounding to 2 decimal places. So again, pay close attention to the question. What is it asking for? Does it want an exact answer, or does it want a rounded decimal answer? Let's practice using the quadratic formula for another question. So we've got x squared minus 7x minus 2. So we're going to have a, b, and c from that. The a is the 1 from the 1x squared. The b is a negative 7 from negative 7x. And the c is a negative 2 from the end. So we substitute all of that in. X is going to be equal to negative b. B is negative 7, plus or minus a square root of. So then it's going to be b squared, that's negative 7 squared, minus 4ac, that's 4, times a, which is 1, times c, which is negative 2. All of that is divided by 2a, which is 2 times 1. Let's start to simplify it. Negative 7 is going to give us just a positive 7, it's double negative. We plus or minus, so the square root of negative 7 is 49. Take away 4 times 1 is 4, times negative 2 is negative 8. So that's 49, take away negative 8. And all of that is divided by 2 times 1, which is 2. Let's simplify our square root. Now we can see it's 49 take away a negative 8. That's a double negative. That will mean that we have 7 plus or minus the square root of 57. And we get that double negative inside the discriminant quite often, with everything being divided by 2. So that's our exact answer. X is equal to 7 plus or minus the square root of 57, all divided by 2. But we can work out decimal answers as well. Let's take plus or minus to be a plus. You type in your calculator 7 plus root 57, get your answer, divide it by 2, and that will give you 7.27 to 2 decimal places. Then we take x to be equal to a negative. That will give us 7 take away the square root of 57, get your answer, and then divide that by 2. And that gives us negative 0.27 to 2 decimal places. And again, pay attention to the question. Is it asking for an exact value? Leave a cert in. Or is it asking for decimals? So round it to an appropriate level of accuracy. And hopefully what you're seeing here is, while the formula looks very complicated, it can be difficult to remember, this working out actually is probably the easiest working out we've done so far. So what you're going to think is, if you've got a really, really basic question, it's going to be fastest to solve it using inspection. You can solve it using all 3 methods, but inspection will be the fastest. You don't want to use a full quadratic formula if you can solve it using inspection. But eventually you get to questions that are a little bit more difficult. And then using completing the square could be the fastest method, because doing it by inspection won't be possible. And completing the square can still be faster and less working out than the quadratic formula. But eventually, when we get the most complicated questions, then the quadratic formula will become the best one to use. So you can choose which of the methods you want to use if you're not told which one to use. But each one is best to use in different situations. Now we'll continue practicing the quadratic formula for the next 2 examples, but I just want to show you a harder example using completing the square, and a good use for completing the square that the other methods can't achieve. So let's look at negative x squared minus 3x plus 1. And let's say it's not equal to 0, let's say it's equal to y. Now if you have y equals negative x squared minus 3x plus 1, that's going to make a graph. So let's sketch a graph. So we have positive and negative axes. And this line will roughly, do a little sketch, will roughly look like this. Let's just label it. Now completing the square can tell us something important about this. And what it can do is, completing the square can tell us where the peak of the quadratic is. So let's have a look at how that works. So we're going to take our negative x squared minus 3x plus 1, and I'm going to start off with completing the square pretending it's equal to 0 rather than equal to y. I'm going to complete the square. Now to complete the square, I want it to be an x squared. It's not, it's a negative x squared. So we're going to multiply everything by negative 1. And that's going to just flip all the signs around. And 0 times negative 1 is still 0. So now we've made it a little bit easier to complete the square for. Then we turn x squared into x and 3x into 1.5x. Now, rather than writing 1.5, which is half of 3, it might be easier to write 3 over 2 for the next part, because it's the same thing. 3 over 2 squared gives us 9 over 4. If we multiply 3 over 2 by itself, we're going to get this extra term that we need to get rid of, if you think back to completing the square. So again, the 2 sections I'm highlighting in green are equivalent to each other. These are both the same. So then we need to take away the 1, and it's equal to 0. So then we want to simplify the negative 9 quarters, take away 1. Now 1 is 4 quarters, so 9 quarters take away 4 quarters is 13 quarters. So that would give us that x plus 3 halves or squared take away 13 quarters is equal to 0. Once you complete the square, the next thing you want to do is just rearrange it so that the number value is on the other side. So if I add 13 over 4 to both sides, I would end up with this. Now you can read out the x and y values of the point on the curve that I labelled by looking at this. We've got the x value and we've got the y value. So the x value is 3 over 2, which is 1.5. You notice on the axis on the negative side of things. So when you take the x value, it's actually going to be the opposite of it. And then it's kind of linked to when you do this by inspection, you know, it's kind of always, the signs kind of flips normally from what you see inside the bracket. With the y, though, it's as you see it, it's going to be 13 over 4. And 13 over 4 is the same as 3 and 1/4. So what we can do now is we can write out some clear final answers. This will be the maximum point of the curve because it's the highest point of the curve. So with a negative quadratic, you're looking for the maximum. If it was a positive quadratic, the curve would be the other way around, and this will be the minimum. But for this, the maximum point, x would be at 1.5, and y would be at 3 and 1/4. So if you ever ask for the maximum or minimum point of a quadratic, you need to complete the square. And by completing the square, those two numbers should appear within your factorized answer. So now let's get back to solving quadratics with a quadratic formula. Again, we're looking at a, b, and c. A is the coefficient on the x squared. In this case, it's 3. B is the coefficient on the x. Now, there's no number there. There's no number. It's going to be a 1. That'll be -1. And then the c is going to be a number at the end, which is also -1. So when we substitute into the quadratic formula, x is going to be equal to -b, which is negative, b is -1, plus or minus, and with the square root, we have b squared, which is -1 squared, and we're taking away 4ac, which is 4, times a, which is 3, times c, which is -1. All of that is being divided by 2a, which is 2 times 3. Let's start to collect bits of this together. So -1 will be a +1, plus or minus. -1 squared is going to be 1, and then we're taking away 4 times 3 is 12, times -1 is -12. All of that's divided by 2 times 3, which is 6. Let's simplify the root. So 1 take away -12, double negative, that's going to be the square root of 13, and it's all divided by 6. So again, there we have the exact answer. Let's look at the decimal values of these. First, let's take x to be a positive. So 1 plus the root of 13, and then divide all of that by 6. The 2 decimal places, we get 0.77. Then let's take the plus or minus being negative. 1 take away the root of 13, divide that by 6, and you should get negative 0.43, again, to 2 decimal places. You need to make the decision, is it appropriate to write down the exact answer, 1 plus or minus the square root of 13 over 6, or is it appropriate to write decimal answers 0.77 or negative 0.43? Again, taking into account the decimal answers have been rounded, they've lost a bit of accuracy. However, they might be a little bit easier to understand. Now, for our last question, again, solving a quadratic with the quadratic formula, we need to identify a, b, and c. So a will be 4, b is -3, and c is -2. Remember, the negative symbols belong with a term after them. If we substitute, x is going to be equal to -b, b is -3. And you can see it's a double negative for that. Be very careful. That's an easy thing to miss. Then we've got the square root of b squared, which is -3 squared, minus 4 times a, which is 4, times c, which is -2. Just look at the way I'm using the brackets inside the square root. This is very important, because if you don't use the brackets inside the square roots, you might get a little bit confused, have a negative number where you shouldn't. And very often, you can find yourself having to square root a negative number and think there's no answers when there are actually answers. Now, usually with a question, it'll make it very clear if it's going to be a question we have to prove it's got no roots, or if there are going to be actual value answers. So you've got an answer line that's x equals, you're not going to write there no answers, no roots. So that's always a sign that you've probably made a mistake. And then go back and just make sure your negative numbers are working properly. So let's simplify this. -3 is 3, plus or minus. So -3 squared is 9. And then we've got 4 times 4, which is 16, times 2, which is -32. And all of that is going to be divided by 2 times 4, which is 8. So now let's simplify the root. 9 minus a -32 is going to give us a 41. And all of that is divided by 8, and that is our exact answer. If you want decimal answers, let's take plus or minus to be plus first. 3 plus the square root of 41, and then divide that by 8, and you get 1.18 to 2 decimal places. Then we take plus or minus be a minus. 3 take away root 41 divided by 8. And that should give you negative 0.43 to 2 decimal places. So depending on the complexity of the question, if you want to find other things like the peaks, the minimum or maximum values of quadratics, you might want to use inspection, completing the square, or the quadratic formula to solve quadratic equations.
Ouch. That'd be too prim.